Alright, we are going to start with a differential problem with an initial condition, and the problem goes like this. You have x times y prime plus y equals e to the x, and with the initial condition being y of 1 equals 2. So first thing I'm going to do is rewrite the left equation as x times dy by dx plus y equals e to the x. Now what I'm going to do is multiply both sides by dx, and I'm going to get x times dy plus y times dx is equal to e to the x. And what I'll notice on the left side is that I have the differential of x times y, because what this is saying is, using the chain rule, you would get the left variable x times dy plus the right variable times the differential of the left variable dx. And you see that's exactly what we have up here. So now I'm going to rewrite the equation like so. That's helpful because if I integrate both sides, and there's supposed to be a dx there, if I integrate both sides, the integral of a derivative equals the derivative of an integral and they just both cancel each other out, leaving just x times y is equal to the integral of e to the x is just e to the x plus some constant. Now the initial condition is that y of 1 is equal to 2. So that's easy enough. Wherever we see an x, we're going to put a 1. Wherever we see a y, we're going to put a 2. So this is 1 times 2 equals e to the 1 plus c. We're just left with 2 equals e plus c. So c equals 2 minus e. So now, taking this equation and writing it in terms of y, everything being a function of y, you get y as being equal to e to the x over x plus the constant c, which we know is 2 minus e, also over x. And there's our solution. However, I'd like to verify that. So what I want to do is take the derivative of the function. The left side is just dy dx, and on the right side, I'm going to rewrite this a little bit different up top. E to the x times x to the negative 1 plus 2 minus e times x to the negative 1. So what we have by the chain rule, again, we're leaving the left variable as it is, and we're taking the derivative of the variable on the right, so that we just bring down the minus 1. So we have minus 1 times e to the x, and then x to the negative 1 becomes negative 2, and then we're adding the derivative, we're leaving the right variable, and we're deriving the left variable, which e to the x, the derivative of e to the x is just e to the x, So we're left with what we started with. Then we're going to take the derivative of the second piece here, and we just have a constant times x to the negative 1, so that's pretty easy to derive. We just have negative 2 minus e times x to the negative 2. So if we look at the initial problem, it said that x times y prime plus y equals e to the x. We're just going to go through and rigorously prove that. So if we take x times y prime, which is all of this, we get negative x times e to the x, x to the negative 2, plus x e to the x, x to the negative 1, minus x 2 minus e x to the negative 2, and then we're just going to add y, which we found was e to the x, x to the negative 1, plus 2 minus e x to the negative 1. So that's a lot, but you end up seeing what you have here is e to the x, x to the negative 1, plus e to the x, minus 2 minus e x to the negative 1, plus e to the x, x to the negative 1, plus 2 minus e x to the negative 1. And we can cancel out these two, and we can cancel out these two, and all we're left with is e to the x. And that's exactly what the initial problem said. It was x times y prime plus y equals e to the x. So that is the specific solution to this differential equation.